Hello everyone, welcome to our exploration of a near real-time analytics architecture using Azure Service Bus and Azure Data Explorer. In this video, we'll explore how we can enhance a simple transactional application that stores data in a SQL database and enable it for near real-time analytics. We will understand the existing architecture and plug new Azure services into it to enhance the as-is state. We will discuss various layers of this architecture and help you understand how the whole architecture works. Whether you're a developer, an architect, or just someone curious to know how this architecture works, this video will provide you with valuable insights. My name is Madhur. Let's get started. Real-time analytics is the process of analyzing data as soon as it's generated to get insights into the current state of the system. Near real-time analytics is a variant of real-time analytics that provides insights within seconds or minutes of data generation. These processes enable organizations to gain insights faster, make better decisions, and respond to changing conditions more effectively. Before going further, we need to understand the scenario and the requirements that the architecture needs to meet. So let's start by defining the requirements. The requirements for the scenario are: 1. Add near real-time analytics to an existing architecture that's part of an operational OLTP application. 2. Provide insights through analytics dashboards. To implement these requirements, let's understand the existing architecture. The data source in the existing architecture is an online transaction processing application. Service Bus is used to manage events generated by this OLTP application. Using Azure Service Bus in conjunction with Azure Functions provides a scalable, reliable, and loosely coupled architecture for handling transaction data storage, ensuring that your application remains responsive even under varying workloads and potential issues with the underlying data storage layer. App Service enables you to build and host web apps, mobile backends, and RESTful APIs in the programming language of your choice without managing infrastructure. Service Bus is a cloud-based messaging platform that connects applications and services with reliable asynchronous communication. In the existing OLTP application flow, it triggers a function app to store data in Azure SQL Database and Azure Cosmos DB. Azure Functions is an event-driven serverless compute platform. It allows you to run code snippets in cloud triggered by events or requests. SQL Database is a fully managed SQL database that's built for the cloud. It provides automatic updates, provisioning, scaling, and backups. Azure Cosmos DB is a globally distributed multimodal database for applications of any scale. After gaining a clear understanding of the current state, we will now explore an enhanced architecture that implements the necessary requirements. The architecture diagram displays all the architectural layers and Azure services. We have already explored layer 1, where the OLTP application hosted in Azure App Service sends data to the Service Bus. The new architecture directs data flow from Service Bus in two directions: the existing OLTP application flow 2A and the new flow 2B for near real-time analytics, which in turn triggers an orchestration flow. The orchestration flow sends data to Azure Data Explorer for near real-time analytics. The flow can use either 1. A function app that uses SDKs to send data in micro batches, or that uses managed streaming ingestion support provided by Azure Data Explorer when it's configured for streaming ingestion. 2. A polling service like an application that's hosted on Azure Kubernetes Service or AKS sends data to Azure Data Explorer in micro batches. This option doesn't require configuring Azure Data Explorer streaming ingestion. AKS is a highly available, highly secure, and fully managed Kubernetes service for application and microservices workloads. Azure Data Explorer is a fast, fully managed, and highly scalable data analytics service for real-time analysis of large volumes of data that streams from applications, websites, IoT devices, and more. Both orchestration flows involve sending data to Azure Data Explorer in micro batches, but they differ in terms of the architecture, implementation, and considerations. So let's compare and contrast the two orchestration flows. The first option talks about the flow using function app with managed streaming ingestion or MSI in Azure Data Explorer. Data Explorer needs to be configured for MSI. MSI in Azure Data Explorer is designed for real-time data ingestion. It simplifies the process by handling the buffering and ingestion of data, reducing the complexity of the implementation. In a serverless environment, you have limited control over the underlying infrastructure. This might be a limitation if you need fine-grained control over resource allocation. Serverless architectures like Azure Functions may have cold start latency, where the first request might take longer to execute. Using SDKs within a function app simplifies the development process. It provides a high-level abstraction, making it easier to integrate with Azure Data Explorer. The second option talks about developing a polling application and deploying it on Azure Kubernetes Service. Data Explorer can be used as is without any elaborate configuration. Hosting your application on AKS gives you more control over the infrastructure, allowing for fine-tuning and optimization. With a dedicated infrastructure, you can have more predictable performance, especially when low latency is critical. Managing the polling application and maintaining infrastructure, updates, and scaling becomes your responsibility. This can result in increased operational overhead. In conclusion, choosing between a function app or a polling service on AKS depends on factors such as development simplicity, control over infrastructure, and operational preferences. With these flows, the architecture provides flexibility when it comes to implementing various use cases. The fourth layer is the analytics layer, where Azure Data Explorer processes data by using schema mapping and update policies, and makes it available through an API, SDK, or connector for interactive analytics or reporting. Optionally, Azure Data Explorer can also ingest or reference data from other data sources like SQL database or Azure Data Lake Storage. Data Lake Storage, built on Azure Blob Storage, provides massively scalable data lake functionality. The fifth layer includes visualization applications, custom services, and reporting services like Azure Data Explorer dashboards, Power BI, and Azure Managed Grafana. These services can query data in Azure Data Explorer in near real time. Power BI is a reporting tool that focuses on business intelligence and data analysis. Azure Managed Grafana is a fully managed service that enables you to deploy Grafana without spending time on configuration. Grafana is also a reporting tool that focuses on monitoring and visualization of time series data. And there you have it. With this extension, we have enhanced the existing architecture and provided multiple flows and options to suit a wide variety of use cases. The updated architecture also preserves the event-driven nature of the existing architecture and provides flexibility to my fellow developers when it comes to implementation. If you found this video insightful, don't forget to like, share, and subscribe. Until next time, stay curious, stay data-driven.